So last class period, what we talked about was the difference of two squares. If I had a squared minus b squared, meaning all I needed to do is if I could find a square term minus another square term, I could factor that into a minus b times a plus b. Right? Well, what about if we just had something that looked like this? A plus b times a plus b. Well, we know that we could write that as a plus b squared, right? Okay. But how do we get to that really kind of point? What would the factored form look like? Well, we have it wouldn't be the a squared plus b squared, but it'd actually be a squared plus 2ab plus b squared. All right? And that is what we call a perfect square trinomial. A perfect square trinomial, when you factor it, becomes a binomial squared. All right? And let me just go and show you an example. X squared plus 8x plus 16. All right? And think about it. What two numbers multiply to give you 16, but then add to give you 8? 4 and 4. So that'd be x plus 4 times x plus 4, right? Which equals x plus 4 squared. Right? So when you guys are looking into these terms, just like when we did difference of two squares, it's not always going to be a squared number minus a squared number. Sometimes you're going to have something like this, 36x squared. And we need to say, can I write 36x squared as a number squared? Yes, you can. We can write it as 6x squared. All right, so be cognizant of that. Be aware of saying, looking at this and saying, all right, I need to find a squared number, another squared number, and then 2 times the square root of each one of those squared numbers. All right, so when those first couple of problems when it says determine if it's a perfect square trinomial or not, that's what you want to be looking for those squared terms inside there. Now, there's a couple things that I want to go over as far as I'm solving. If I have x plus 5 equals 12, all right, to solve this problem, I would have to do what? What would I have to do to solve this problem? Subtract 5, right? Use your inverse operations, x equals 7, correct? Everybody feels okay with that? Good. What about if I said x squared equals 36? What would I do for that problem? How would I solve for x here? I would take the square root, right? You're taking the inverse operations. If you have addition, then the inverse operation is subtraction. If you have multiplication, the inverse operation is division. If you have squaring, the inverse operation would be to square root. Now, one thing to remember, when we introduce the square roots, you have to make sure you include the positive and the negative version of that value. Right? Because 6 times 6 is 36, and negative 6 times negative 6 is 36. Right? So when we introduce the square root, make sure you include both values. So now let me give you one last problem, which we call the square. What about if I gave you an expression? Let's just do this. Let's do it. Yeah, now what if I give you an expression squared? Does anybody know what I'd want to do for this one first? I'm going to want to take the square root of each side. Now, why would I not, and this is a great question, why would I not want to add first? Why would I not want to add the 3? Because what? It's in the parentheses. And when we're doing inverse operations, when we're solving, we do the reverse order of operations. We got to make sure we undo our squaring function first, then we can undo the addition. All right? So yes, I'd square root both sides first. Then I have x minus 3 equals plus or minus 4. And then I'd add 3. Therefore, x is going to be 2 answers, which will be 7 and negative 1. All right? So, that's a very important part. And what I want you guys to understand about that is when you have a problem, let me stole my eraser. Okay. When you guys have a problem, and let's say it's this problem, and I say solve, remember when we're solving, we're setting our function. When I say solve or find the x-intercepts or find the zeros, we're taking our function and we're going to set it equal to 0, right? And actually, in your worksheets, you're already set equal to 0, so that's cool. But in your pre-calculus book, if you have a function that say find the zeros, you can just set it to 0 by yourself. Now it's set to 0. What is the factored form of this? 0 equals x plus 4 squared. And then you can do the square root of both sides, but you just see that the only answer for here is just going to be -4, because 0 doesn't have a plus or a minus. All right? So anyways, when you guys are doing the square root function, that's what you guys want to be looking for, is trinomials that are in this form, because if they're in this form, you can write them as the binomial squared. Okay? Any questions? No? Good? All right, so you're